Well, hello everyone. Dr. David Ajibade here with the Brain and Body Foundation, and welcome to Your Health in Your Hands. Now, as you know, with the foundation, we've been granted permission. No, I would say we've been mandated by the federal government to do all this education, all this teaching that we're doing to you today and every other day. And there are three main areas that I like to focus on when we're getting a guest, and we are going to have a guest on today. One is teaching Nigerians about basic fundamental principles when it comes to health. What you should do, what you shouldn't do, foods to eat, foods to avoid, uh, things to do with your cell phones, whatever. Those are things that you know and I know that many times we tend to overlook, and this could be to the detriment of our health. Number two, we like to focus on things that affect Black people specifically, because again, as you know, we Black people have certain weaknesses that, in my opinion, should be emphasized and highlighted. And that's why I talk about vitamin D3 so much, because we are deficient in vitamin D3, not just in Africa, but around the world, especially in the US and temperate parts of the world like the UK, where during the winter you get really, really cold and nobody's going outside, the sun isn't shining like it should, and people are deficient in vitamin D. Everyone is deficient for the most part in vitamin D during the winter, more so Black people. And it's not just about vitamin D. There are other things we have to talk about too. And that's why I'm so grateful to the top brass at NTA over there, especially Mr. Coker, who are happy to let us start talking about these issues, because I think Nigerians and Africans really, really need this. Now, the third thing, which I'm particularly excited about, is the ability to translate, to see what they're doing in third world countries, the healthcare discoveries that are being made, and translate that into our settings, our context in Africa, in Nigeria, and make it applicable, make it usable and transferable, not just in the cities, but in the remote areas. In other words, where if Mama Sikira or Yamodina has a child with a brain disorder or whatever it is, we should be able to help that person in a safe, complete, efficient way that doesn't cause any more problems for the child. And that is why we have on our show today, Dr. Stuart Campbell. Stuart, thank you so much for making the time to do this show today.
I'm very pleased to be here, and I'm appreciative of the invitation and the chance to speak with you. Thank you.
Absolutely, and you are such an accomplished person. Your CV, your resume goes as far as I can see. So I'm just going to ask you, can you just tell us about yourself, and before we get into the show and what we can talk about today?
Sure, I'd be happy to. I'm Canadian originally, so born and raised in Canada, and my education was in chemistry in Canada. I have a PhD in chemistry, and I immigrated to the United States in the early 1990s to become part of the biotechnology and pharmaceutical industry, because I wanted to operate in a world in which everybody was aligned and motivated to uncover the basis of different diseases and then develop new treatments for those diseases based on what we find scientifically. So over the last 25 years or more, actually, I have been fortunate to work with very talented people here in the US and also in Canada to help bring several drug candidates from the laboratory setting, where we do the very early research to understand whether a drug might have some promise in a particular disease, all the way through to late-stage clinical trials in which we are evaluating those drug candidates for the right profile. Do they work against the target disease, and are they safe for the disease population to use for that disease? And so in my current role now at Axial Therapeutics, we are focusing on the relationship between what we call the gut microbiome and the brain. And what we mean by that is, as you may know, our gastrointestinal tract is populated with trillions of microbes, mostly bacteria, but also viruses and protozoa. And they obviously have a very intimate relationship with the human body. And so within that, we have learned to live with each other and benefit from each other. And so we like to understand both how that gut microbiome can contribute to disease, but also be a place to look for things that could help treat disease. And that's how I've ended up at Axial Therapeutics, which is based outside of Boston, Massachusetts, here in the United States.
Fantastic. I didn't know you were from Canada. I would have guessed.
I tried to lose the accent when I was much young, so I think so far I've been managed to do that. Yes.
I think you've done a good job, because I usually catch that accent. Sometimes I have trouble with differentiating the Minnesota accent from a Canadian accent, but yeah, you've done a really good job. So congratulations on that.
Thank you.
So I don't know if you mentioned this. I don't know, or if I don't know if folks heard this, but you are the CEO of Axial Therapeutics, right?
That's correct. Yes.
I know you're being modest about this, Stuart, but come on, we gotta bring these things out, right?
All right. Sure. Yes, I'm the CEO and also the head of research and development as well at the company.
Fantastic. And folks, one of the reasons why Stuart has been Dr. Campbell has been so gracious to come on is because we reached out to him. As you know, we do a lot with autism and brain disorders. Hey, we're called the Brain and Body Foundation, after all. Was that we found out that we were getting results with our kids with autism and other related disorders, as well as with our parents, our older people with dementias and other conditions, but we're only getting so far. I mean, we're getting great results from our therapeutics. Again, the federal government has mandated and given us the authority to use this management, use our approach called the building strength approach to this. But we could only go so far. Every time we would get to a stop, and we wouldn't see as many improvements as before. And so we began to look around, and we realized, just from researching, that there were other steps that needed to be taken. And that's what led us to Axial Therapeutics and Dr. Campbell and his team, because they are coming out with some really innovative approaches that can significantly improve mental health. Another thing is, if you are on this, if you're watching this right now, please, please, please reach out to your neurologists, your psychiatrists, everybody in the mental health field, because this is a topic that is of particular importance. So, Doc, how do you think what you're doing is going to affect the way mental health conditions are going to be treated? How is it going to revolutionize what we're doing in the mental health field?
I hope we're going to revolutionize it. And so I think first is, at least in North America, there's been a groundswell of social recognition that mental health is a real thing that is treatable, and it's treatable in many different ways, not always with drugs, but sometimes with therapy and other interventions. And this is, I think we're finally, after generations of denial or failure to recognize that mental health is a significant contributor to not just the way people behave in society and how they behave in their relationships, but also in how they how we think about it as a society. How do we deal with people with mental illness and with it's not always mental illness, but maybe a neurodegenerative disease that leads to dementia, for example, or memory loss, which these are real things with biological etiologies. And I think we need to, we're finally starting to appreciate that there are some tractable mechanisms that contribute to this. It's not that we can solve every disorder or disease at the moment, but we think that the work that's going on right now in the field is actually, it's a very exciting time to be doing research in mental health. Go ahead.
So tractable, can you give us some examples of some of the things that you begin to see that can significantly improve the results we get from?
Yeah, and I think you see a lot of so part of the challenge with a lot of these indications is that we don't know what causes them. And so until you know what causes them, it's very hard to look for the right things that may change or might be an indicator of somebody who's at risk for developing a certain type of disorder or disease. For example, there's just a tremendous amount of research being done in Parkinson's disease and Alzheimer's disease to try to predict those who are at risk for developing these. And the idea would be to try to identify them before they get diagnosed. And there are some signs there, especially in Parkinson's disease, where you can look at other things that happen to them prior to their diagnosis. Are big indicators of risk. And if you start to, the more we do epidemiology research and profile people who have the disease versus those who are so far healthy, and you can start to develop through a lot of artificial intelligence type of algorithms to understand what parameters contribute to their risk. And then maybe you could identify a population well before they get diagnosed, and you could change the trajectory of their life as a result. So to me, it's a combination of several technologies that are really becoming mainstream. One is genetic profiling, or sort of understanding at a genomic level what genes are associated with a disease risk. And this applies not just for neurodegenerative diseases like Alzheimer's and Parkinson's, but also neurodevelopmental disorders like autism, for example. And so there's genetics, there's environmental factors that could contribute to either whether somebody gets a particular disorder or disease, or maybe how quickly it progresses or how severe it gets. And it's this interplay between the environment and the genetics that is just something that we're beginning to understand now. So it's not that everybody with a particular genetic profile is guaranteed to get a disease, but it's usually in combination of putting that person in a particular environment. And by that, I mean, it could be exposure to certain foods, it could be exposure to certain chemicals in the environment, et cetera, that may hasten their progression to a particular disease state. And so there's a lot of these things that now, with the computing power and the algorithms available, we can actually take massive amounts of data and process it in a way that we can start to predict better outcomes and risk factors and things like that. So I feel like we're really on the cusp of being able to, in a way, decode mental illness in a way that we could never do before. So it's really exciting.
It really is exciting stuff, fascinating stuff. Well, here's the problem, Stu. The challenge is that we in Nigeria and Africa, we usually present when the disease has already developed to a certain stage. So many times we don't look as much, or we're not paying as much attention to the risk factors. So we need, by the time we come to the doctor, for the most part, whether it's cancer or dementia or whatever it is, it's usually advanced. So surely there are things, and this is again why I approach you all. Surely there are things that can be done even after we've not been able to prevent, after we've gotten a condition like that. So yeah, we're going to have to take a break here, and then we will come back. But please, let's answer those questions.
Sure.
I know you're being modest, but we got to get some concrete answers where these things are concerned.
All right.
So we'll be back soon. Stay tuned, folks. Okay, awesome. Now, okay, are you I know I'm pushing a little bit, but people want to know, they want to know if there's any solutions to those things.
Yeah, and I think so I can certainly switch gears and get more to concrete. What can you do, right? So we could get into like risk factors, but also what contributes to somebody with autism, right? For example.
Correct. Right.
Obviously, there's about 100 genes that are known to be associated with autism.
Yeah. So we might want to skip those because people will not want to hear about that. They want to know, like the mother will want to know, okay, is there something that can be done? I know at this point the drug isn't out yet,
Right.
but if we could talk about it without revealing anything that you don't want to be revealed, just to give people hope that, yeah, we're getting to it. We've tested whatever, and this is things that we're finding. And in the next year or decades, we should be able to see we should have hope for these people. So things like that.
Yeah, okay.
Same thing with dementia too. Is there something that can be done to alleviate, to improve their symptoms, things like that, that we're now finding out?
Yeah.
Okay?
Yeah.
Okay.
Sure.
Cool. All right. We're going to get back now. All right. Welcome back, folks. Now we're talking about things that can be done to improve brain function, even when it seems like all hope is lost from a medical perspective. But by the way, folks, before Dr. Campbell answers this question, there's going to be a longer presentation that's going to be on our website, brainandbodyfoundation.org, where Dr. Campbell goes in depth to really talk about some of the science. So this would be something of interest to you doctors out there, you researchers out there in the mental health space. I really, again, encourage you to speak to your neurologists and psychiatrists and people that you know that would be interested in this, because this information is valuable and it's free right on our site. You can go there and download it. Okay. All right, so you talk to us.
So let's use autism as an example. Okay, so autism is, at least in most countries in the world, the incidence of autism is increasing. Not just because we're getting better at diagnosing it, but there's something else going on, right? It is showing up more and more. And so we started looking, and when I say we, I'm referring specifically to the scientific founder of Axial Therapeutics, who's a professor at Caltech, Sarkis Osmanian, who started over a decade ago looking at the relationship between the gut microbiome and autism. And it's known that a very high percentage of kids with autism have GI symptoms. They either have constipation, or they have diarrhea, or they oscillate between constipation and diarrhea, and it's a very has an impact on quality of life for sure, on them and the family. And so that was the first indication that there could be a role for the microbiome. And so we went through a very elaborate set of experiments in mice to establish that there is a set of metabolites. And these are small molecules that the gut microbes will make as part of their living and reproducing in the gut. And they make thousands of metabolites, and most of them are very good for us. So roughly half of the metabolites that are circulating in our blood at any one time come from the microbes in our gut.
No way.
Yes, absolutely. And so we would essentially be dead without these microbes. So we usually think of bacteria as bad. We need to kill them and get rid of them. But frankly, we would be in a really bad situation if we had no microbes in our gut. So we've co-evolved with each other in a way that they benefit us and we benefit them. And it's only when things get out of balance a little bit, or a particular type of microbe starts to do something that's not advantageous to the human, that you start to see some of these changes in the human, right? So behavioral changes, or could be physical changes, etc. So the microbes talk to the human all the time, and vice versa. And we have a very intimate relationship. And one of the ways in which the microbes communicate with us, and vice versa, is through these metabolites. And so they get into the bugs, produce them in the gut, and they make it into our circulation, into our blood. And we've shown that some of them can actually reach the brain. We've shown this in mice, at least. We don't know if this is really the case in humans yet, but we hope to figure that out soon. And they can alter behavior. And we're starting to get a good view of how this is happening. And there's all kinds of techniques to try to decipher this. But the bottom line is this, that we know that if you can eat a variety of food, of different foods that are natural, that have high fiber, et cetera, and you can develop a healthy microbiome. And healthy is still a matter of debate, like what is a healthy microbiome? Generally speaking, the more diverse the organisms are that live in you and the more of them you have, the better, generally speaking.
Right.
And so when you see somebody and so what people have found is that kids with autism have a different microbiome from kids that are same age and same status that don't have autism. Even living in the same household where you'd expect their microbiome profiles to look very similar, they're in fact different. We have to be careful though, because kids with autism will often have very significant dietary restrictions. They would only eat certain kinds of food, certain colors, certain textures. And so we don't want to overinterpret that result, but what was clear with our research was that there's a difference in what metabolites are produced by the microbes in autism populations compared to matched control populations. And what this means is that there's a different profile. Some things are elevated, some things are lower in the autism population compared to the controls. But that's all correlation. It doesn't mean that it's actually causing or helping in any way. So then we would have to go back into mouse models and so on and start to deliver these metabolites in ways that could tell us whether they actually are making the problem worse or making it better. And we've done that. And based on that, we're developing a drug that actually you take by mouth. So it's an oral medication. It's a powder you mix with some food, and it's actually very easy to take. And it goes through your gut. It does not get into elsewhere in your body. It doesn't get into your blood or go to your brain or anything. It stays in the gut. And what it does is it's like a sponge, right? So it sucks up these metabolites that are being produced in the gastrointestinal tract, and it ushers them out in the stool as opposed to having them get absorbed and go into your circulation. So it's our way of essentially depleting metabolites that are produced by microbes that we have shown can contribute to some of the symptoms related to autism. So our idea here is if we can reduce those in the gut, we'll see a reduction in the blood, and we should see positive changes in behavior as a result. And so we did a small clinical trial. We finished it last year, and we actually showed that in adolescent boys with autism, that we were able to significantly improve their irritability and anxiety levels. And this is something that, even though those aren't part of the formal definition of autism, they do show up as co-occurring conditions in many, many kids with autism. So a significant portion, they'll have high anxiety or they'll be highly irritable. And by irritable, that translates into tantrums and self-injury and violent outbursts and things like that. That can get
and hyperactivity.
Hyperactivity is another manifestation that we do see in kids with autism, and a lot of kids in the U.S. that have autism are treated with ADHD medications, and so. But this irritability and anxiety are things that are not well managed in this population. And we saw in mice that we were able to reduce the anxiety. And so we looked in the kids, we saw a similar reduction in anxiety that corresponded to reductions in these metabolites. And then we took the drug away and the metabolite levels went back up and this irritable behavior came back. So we now have these evidence that when we lower the metabolites with this drug, behavior gets better. We take the drug away, the metabolites go back up, and the behavior gets worse again. So we have, I think, the beginnings of a proof of concept in human population of this new way of thinking. So take a step back for a moment and say, okay, what you're telling me is we have a behavioral disorder in autism that people normally equate with something going on in the brain.
Right.
Probably the case, but that we can treat by hitting something in the gut and actually have an impact on behavior. And we've seen this now in our clinical population. So we are just about to start the next wave of clinical studies here at the company. And our goal would be in the next few years to get all the way through the clinical trial process and get this drug introduced to the market for treatment of irritability associated with autism, let's say. All based on an understanding of how the gut bacteria communicate with the human host. It's an entirely new concept. The only way we could have got to this point is if we are able to develop a hypothesis or a theory around how this works based on all these technologies that are now available to us that weren't available to us 10 years ago. So it's a really exciting time.
You know, that last thing you said, basically you're saying that if you ignore the brain and ignore what's going on in the brain and just focus on the gut, and you correct me if I'm hearing you wrong, if you just focus on the gut, you can achieve a lot more than what people who have worked on the brain, neurologists, psychiatrists, etc., have been achieving. Or correct me. I want to be sure I understand what you've just said.
Okay, no. So I would not go that far. Okay. So I would say that all the work that's being done by neurologists, psychiatrists, etc., who do think about a mental illness from sort of the neck up is pivotal. We need that.
Right.
And this is because ultimately that's what's driving the actual behavior. It's all being driven by the brain. However, the things that can impact the brain and how the brain responds don't always have to come from within the brain. They can come from elsewhere.
Got it.
Right? And think about this. If you are hungry, something's telling your brain you need to eat. Well, that's not something inside your brain. It's something in your gut that's telling you you need food. So that's a communication between the gut and the brain. Similarly, when you've eaten enough and you need to stop eating, there's a signal that comes from your brain to the gut to say, you need to stop eating now, right? So everyone's familiar with that kind of communication between the gut and the brain. Or if you're nervous about something and you get what we call butterflies in your stomach, you get a little bit of a queasiness in your abdomen when you're nervous. That's a gut-brain communication. So why can't it be communicating in all these other ways as well, where the outcome is behavioral change, right? And this is all we're talking about. So it's not to forsake anything about what's going on in the brain. It's just to understand outside of the brain, what are some of the other ways in which things outside the brain can contribute to brain activity and behavior.
Okay, so this is a more inclusive approach.
Yeah, absolutely.
Brain disorders and mental health disorders. I think it's crucial. I think it's revolutionary, and that's fantastic. I mean, this may be the missing piece. Again, like I said in the beginning, this may be why we haven't been getting as great results as we could have been getting in the mental health fields, because we haven't been paying attention, or maybe because we didn't have the technology to really find out exactly what exactly is going on in the gut that is causing these problems in the brain. I mean, one of the most impressive things I ever heard was that the serotonin, over 95% of the serotonin is made in the gut.
Yeah, the vast majority of things like serotonin, dopamine, they're massive levels produced by the gut. And if you think about this, the gut doesn't operate in a vacuum, so to speak. There's this whole thing called the enteric nervous system, which is a really complex neural network that regulates the entire GI tract from your nose all the way to the anus. And so you have now, how are all these functions controlled? And so there's a set of neurons together that function as the enteric nervous system. And so why wouldn't there be neurotransmitters associated with that? I mean, neurons communicate in the same way.
Right.
They're the neurotransmitters. So there's going to be massive amounts of these neurotransmitters in and around the gut. And sometimes bacteria actually can produce these neurotransmitters. So they can supplement what we would make as the human, or sometimes they're the exclusive source of the neurotransmitter. And so this is something that I think people really didn't appreciate a decade ago. And so if you think about, you talk to most neurologists a decade ago and you say, I think there's something going on between the gut and the brain, and the gut is somehow impacting behavior, and they would think you were crazy. But now with the technologies and all the research that's been done, it's coming into the mainstream. There is some real biology going on there that is helping us understand brain processes and mental illness in a way that we couldn't before.
That is absolutely exciting stuff. And I hope, Stu, that while you're doing all this research, that you remember that you think about us Black people as well. So you do the research on us Black people as well. Because from what I've seen, we don't all react in the same way as white people do. So
that's a fair point, and we fully recognize that the medical research field, certainly in the North American and European continents, has been not as diverse in its evaluation of populations as it needs to be. And that's clearly something that you see a lot of work by, for example, the NIH here in the US, demanding that if you're getting money from the NIH and you're doing a clinical trial, there's a whole section where you have to address diversity. So, and so there are some active steps being taken by the major agencies here to make sure that we have a much more representative and inclusive approach to this research, more so than we ever did.
Fantastic. Well, that's great to hear. We're going to have to stop now because we've gone a little over time, but folks, just remember, like I said earlier, there's another recording, a more detailed recording that will be on our website, so you can access it over there. And hopefully we'll get Stu back on to talk to us some more about some of these wonderful discoveries. But at this point, we do have to end the show. So Dr. Campbell, thank you so much for taking the time to do this.
Oh, you're very welcome, and it's been a real pleasure. And I hope to see you again soon.
Absolutely, looking forward to it. So folks, take care, stay safe, maintain all that social distancing and masking things, but be sure to be healthy and boost your immune system as well. Till then, God bless, and we'll see you soon. Bye. Awesome. So I'm going to end this.
Okay.
Then I'll start another one. I'll send you the email right away with a link to that.
Okay. Sounds good. So I'll log off then.
Okay.